November 3, 2020. The day America chooses its next president. Also on the ballot are important issues for voters to decide on. Things such as establishing a redistrict commission, allowing veteran car tax exemptions, and perhaps the most contentious debate of all, is the use of cruise boosting in battle for Bikini Bottom legitimate? Oh shit. The votes are in. Donald has won again. Let's tune into Trump Tower and listen to his victory speech.
People always tell me it's a horrible thing, cruise boosting. It came from China and it came from Hazel. Starting today, the first day of my second term, we are going to get rid of it. Playing the game without cruise boosting is something Sleepy Shift has never been able to do. We are going to make the FBB great again and restore the honor of the developers by patching this terrible exploit.
Well, Mr. President, we better get to work. Let's listen to Shift to see how he thinks cruise boosting works.
Let's start talking about cruise boosting. What does it actually do? If you've seen runs of the game before, you know what it looks like, but do you really know what's happening under the hood? Well, let's start by saying that cruise boosting is a glitch that allows you to lock your bowling speed at a certain value by inputting the bubble bowl and the cruise bubble on the same frame. In Battle for Bikini Bottom, the game runs at 60 frames per second on all versions. This means that you have 1/60th of a second window to press the bubble bowl and the cruise bubble on the same frame to lock whatever bowling speed value you have at that given frame.
Let's see if we can do it. It sounds like all we have to do is run into a wall and press the cruise bubble button and bubble bowl button at the same exact time. Let's give it a shot. Okay, not as easy as I thought. There we go. We successfully cruise boosted. Now we're automatically moving and it's also making the terrible noise. I already feel sick to my stomach for exploiting the game. Now let's investigate the game's source code to see if we can figure out how to patch this. We are going to be using an advanced reverse engineering tool made by the NSA called Ghidra to inspect the game's code. Boom. Here we are in Ghidra after loading in and processing the GameCube executable. If you don't have a computer science background, you're fucked. Do you really think I have enough time to explain all the shit that's going on here in a 9-minute and 46-second YouTube video? No, I'm going to give it to you rough, dry, and fast. The first thing you should know is that when Heavy Iron released the game, they forgot to remove the symbol names from the GameCube executable file. This means we can see the names of every function in the game, as well as the types of their parameters. And yes, these are the exact same variable and function names that the developers used in their code. For example, fucking surface type, and assume player is stupid. It seems one of the programmers at Heavy Iron had a bit of passive aggression. Let's take an educated guess and search for anything with the word bowl in it, to try and find something related to bubble bowling. It looks like there are a bunch of callback functions which are likely called during different points of the bubble bowling process. Let's take a look at the one called bBowlCheck. The ugly code you're seeing here is Ghidra's attempt at automatically decompiling the function from assembly to something close to readable C code. This function appears to be returning a boolean value of true or false, as to whether or not the player can bubble bowl. We can see it is checking to see if the player is in a teleport box, and if not, it also does some special checks on global variables. At this point, we don't know much about the details of this function, or the meaning of the global variables being checked. Our first task is to pick this apart and figure out what's going on. Fortunately, there has been a related project started by SEAL called BFBBDecomp, where we are attempting to reverse engineer the source code of the game line by line until we can create a matching copy. However, this project is going to take a very long time and has only just begun. As you can see, we only have figured out the source code of less than 1% of the game. We can however use the tools in this project to help us in our effort to reverse engineer the bubble bowl function from earlier. After studying and reverse engineering the assembly code for a few hours, and after much trial and error, I was finally able to decompile it. And here it is, the exact source code that the developers wrote. It matches the assembly perfectly. Let's look at what this function is doing. First, if the player is in cheat mode, they can't bubble bowl. Next, if the player is in a teleport box, they aren't allowed to bubble bowl. Then, There are 3 conditions the game checks for that must pass for the player to be able to bubble bowl. It first checks to make sure the player has control of SpongeBob. Then it checks to make sure a specific button on the controller is pressed. Finally, if those checks pass, it checks to make sure the player has unlocked the first power-up. If all of these checks pass, the player can bubble bowl, and the function returns true. Now we get to the fun part. Let's mess around with this code and see what we can learn. Let's make it so the game updates our shiny count every time this function is called. It looks like the function is called every frame where SpongeBob isn't already doing any kind of action. Every time the shiny is being updated, here is an opportunity to bubble bowl. Therefore it is also an opportunity to cruise boost if it were paired with a cruise bubble at the same time. The game maps the state of each button on the controller to a specific bit in this variable. This is being read from to determine if a button is pressed by logically ending it with a constant value. As we can see here, the state of the bubble bowling button is the 17th bit in this 4-byte integer. We know that the bubble bowl button is mapped to the 17th bit, but how do we figure out what the values of the other buttons are? To figure this out, we can loop over every bit in our controller map and check to see if that button is pressed. If it is pressed, let's write the bit number to the screen so we can see what its value is. So we can confirm bubble bowling is the 17th bit. Jumping is 16, bubble wand is 19, and most importantly, the cruise bubble button is mapped to the 8th bit. Patching cruise boosting should be simple since we know that it relies on the game not handling the player inputting 2 different actions on the same frame. Let's add an additional check after the player has been confirmed to be bubble bowling. If the player is also pressing the cruise bubble button at the same time, we know that he's a dirty cheater who is attempting to cruise boost and should be punished. Let's hurt him and also deny his cruise boost request.
Ow!
Ah, music to my ears.
Ow! Ow!
17 years after the game's release, the cruise boosting glitch has been patched. But wait, our work here isn't done yet. There is also another glitch that the degenerate speedrunners use to abuse the game called Hands Disable. Hands is the name of the hand which grabs the player if they travel out of bounds and puts them back on the map. Shift describes how disabling the hand can be done.
Now we're coming up to the most important glitch in the entire game. The first thing you do when you walk out of the pineapple is go to the taxi pad and lay next to it. When the hand grabs you, select yes to confirm the taxi prompt. Walk back to the taxi pad and lay in the same spot you did before, and the hand should grab you and drag you into the loading zone over the taxi pad. And if you did this successfully, you should have the hand disabled.
This glitch is the foundation that enables many other game-breaking glitches and exploits. It must be patched as well. By searching for variables containing the word hand, I was able to find this structure which appeared to hold out-of-bounds information and timers. It also has a variable named flags, which I assumed held the state of the player. After displaying this value on the screen and recreating the glitch, I observed that under normal circumstances, only the first 2 bits are set. When the hand is disabled, the 3rd bit is also set. Therefore, patching this should also be simple. We can include our fix in this function as well since it runs on virtually every frame. We can check to see if the player is in control. If the player is in control, and the 3rd bit is set, meaning the hand is disabled, we simply toggle that 3rd bit and then kill the player for his sin. Now when the player attempts to set up this glitch, he will be quite surprised to find out that when he loads into jellyfish fields that he immediately dies. He will also be disappointed to find out that he can no longer travel out of bounds and that his attempt to cheat the game has failed once again, proving that cheaters never prosper in life. Now that the game's most infamous glitches have been patched, players will have no choice but to complete the game the way the developers intended. The battle for Bikini Bottom speedrunning community is now on suicide watch as half a decade of gameplay theory and routing has been thrown out of the window. When forced to play the original game, they will realize that they never actually enjoyed the game. They only enjoyed the sadistic thrill of exploiting and abusing something which was once pure.